In this video, we have another example practicing balancing equations and also predicting the products, and we're going to review how we get the formulas for the chemicals we see. So this says predict the products when solutions of magnesium bromide and phosphoric acid are mixed. So magnesium is referring to my yellow color, magnesium right here. And magnesium is a metal, and it's in the second column of the periodic table, which means it has 2 valence electrons. It would like to lose both of those valence electrons, so it is going to form a positive ion that is a 2+ charge. And then bromide is referring to bromine. Bromine is over here on the nonmetal side. It is a halogen. It has 7 valence electrons, and it needs just 1 more to get to 8 to have that complete outer shell. So it is going to have a charge of 1-. So to write the formula for magnesium bromide, we're going to need 2 bromide to make a neutral compound. So the formula is MgBr2. And then it says solutions of, so implying that both of these are aqueous, dissolved in water. Then the other compound, it says phosphoric acid. So the ic means that the polyatomic ion that it was derived from ended in 8. So 8 turns into ic, and ITE turns into us, like nitrite becomes nitrous acid. So anyway, phosphoric means it must be talking about phosphate, and phosphate is PO4 3-. So that is something you do need to memorize. Phosphate is PO4 3-. And now since it's a 3-, and being an acid, we're going to pair it up with positively charged hydrogens. It's going to need 3 hydrogens to make a neutral compound. So H3PO4 is the formula for phosphoric acid. And it is also aqueous. Now we got to predict the product. So again, think about double displacement. So that's kind of like the strategy to help you predict the products, which means imagine like the magnesium and the hydrogen are switching places. So that means, I'm going to write it down here and we'll actually put the products. But we have magnesium ions being paired up with phosphate ions, and then we'll have the hydrogen ions being paired up with the bromide ions. And then you have to think to yourself, okay, how many of each are going to be necessary to form a neutral compound in each case? With the hydrogen and the bromide, that's pretty easy because they're both just 1. Hydrogen's 1+, bromide is 1-, so we would make HBr. But with the magnesium and the phosphate, it's a little bit trickier. And there's a couple tricks for it, like there's the crisscross method where you just take, oh, that goes there and that goes there. But it's better to kind of think of it as, how many am I going to need to make a neutral compound? So since magnesium's 2+ and phosphate's 3-, the common multiple, or the least common multiple, would be 6. You think like 2 times 3 is 6, and here 3 times 2 is 6. So if I had 3 magnesiums, and sometimes it even helps to draw it 3 times, if I had 3 magnesiums and 2 phosphates, here I've got a total charge of 6+, and here I have a total charge of 6-. So the formula that results is Mg3, and then we're going to need 2 phosphates. We use parentheses anytime we have multiple copies of, and I just wrote 3, I meant to write 2. Anytime we have multiple copies of a polyatomic ion, we like to put it in parentheses. So I have Mg3PO4 parentheses 2. So I'm going to go ahead and write that as our products. So Mg3PO4 2, and then HBr. Now for the states of matter, we talked about our solubility rules. So one rule is the group 1 metals. Another solubility rule is anytime you see a nitrate compound. And the next favorite simple rule, ammonia compounds. And there are more than just these 3 solubility rules, but these are the 3 solubility rules that do not have exceptions to them. So try to memorize these if nothing else. But for magnesium phosphate, that's the name of this first compound, that first product. Magnesium phosphate, none of the rules imply or tell us that it is soluble. None of those rules are saying that it dissolves in water, so it is very safe to assume that that is a solid, so we just label it as a solid. Now, HBr, that is a strong acid, so strong acids and strong bases will dissolve in water, so we will label it aqueous. Now, if we're actually balancing, and I'm going to erase some of my work here because we're going to do that column strategy where we're going to keep track of the elements so we can figure out if it's balanced. So here's my column. And I think I'll do it by the polyatomic ions like I've done before. So I've got magnesium, bromine, hydrogen, and since my phosphate is staying as a single unit, I think I'll go ahead and write phosphate. It's just a little trick that you can do. It works in many cases, like when you have double displacement reactions or acid-base neutralization, you're forming precipitate or something like that. This is a good little shortcut strategy that works out quite nicely. So we start off by counting the number of atoms we see on both sides. So like magnesium, I see 1 on the left, 3 on the right. Bromine, I see 2 on the left and 1 on the right. Hydrogen, 3 on the left and 1 on the right. And the phosphate, I have 1 and 2. All right, so kind of trial and error approach. Think about, okay, what is messed up? What should we focus on? Maybe let's try to the magnesium first. Let's fix that. So that means we'd want to put a 3 in front of the magnesium bromide. And we have to update our counts each time. So now this becomes a 3, but now my bromine, so 3 times 2, that means I have 6 right here. And let's see, let's go ahead and do something about the bromine next. Why not? So 6 bromine on the left, only 1 on the right. If I put a 6 right here, then that makes that 6, but now my hydrogens, I'm going to have to recount that. So hydrogens now become 6. Now phosphate and hydrogen, so I noticed that what I have on the left side, I need to double it. So hydrogen, I have 3, I want it to be 6. Phosphate, I have 1, and I want it to be 2. So if I just put a 2 right there, then my hydrogens are now 2 times 3, so that's 6. And the phosphorus, it's 2 times the one that was already there. I meant to do undo. There we go. So that becomes 2. So now just looking through it, we got magnesium is balanced, bromine is balanced, hydrogen is balanced, and phosphate is balanced. So it's balanced.